Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to discuss about the area, arc length, and the surface area of the parametric equation. So, first of all, the area, we will take it. Then, this is the regular function for f of x equal y equal f of x. This is the area, integral a to b y dx. This is the y equal f of x function. Now, in place of the parametric function, we will assume this one as x is equal f of t and y is equal g of t. So, I just replace this part in place of x and dx. So, you will get it here. This one is the g of y, that is a y, and derivative of x, it is f prime and dx. So, this is the formula we are going to use in the problem. So now here there is a area is asking for the area of one arc. So you have to take it this one as a cyclide of the cyclide. So first of all, I write it the formula. This is the area is equal integral the pi. This is the cycloid. For the cycloid, you will have 0 to 2 pi. So this is x-axis, this is y-axis, and the points are 0 to 2 pi r. So this is the cycloid form. So one cycloid. So the remaining it goes the next one. So I have to take it. This one is a radius to r. So the angle is 0 to 2 pi. So we will take it 0 to 2 pi. Now y dy, y dx. So here integral 0 to 2 pi and just substitute the value. So here y is nothing but r. So r 1 minus cosine theta and dx. What is dx? So differentiation of x is equal. So r is a constant. I have to differentiate this one with respect to theta. So here dx over d theta which is equal, r is a constant, 1 minus cosine theta. So it is 1 minus cosine theta into d theta. So this is the differentiation. Now I have to multiply this part. So when you multiply, you will get integral 0 to 2 pi, and r into r is a constant. You can take it outside. This is r square. And here, if you multiply the same part, you will get whole square. 1 minus cosine theta whole square into d theta. Now you can expand using a minus b whole square. So you will get 1 minus 2ab, a square minus 2ab plus b square into d theta. Now again, I have to go with this one as cosine square theta. So cosine square theta is 1 plus cosine 2 theta over 2. So this is the formula for cosine square theta. Now just I write it this part as it is. So you will get x square here 0 to 2 pi 1 minus cosine 2 theta plus into d theta. If you simplify, if you separate this one, you will get it integral 0 to 2 pi. The first term is 1 minus 2 cosine theta, and here it is 1 plus 1 over 2 plus 1 over 2 plus cosine 2 theta over 2. So this is the, I just separate the 1 over 2 here. So now I will simplify 1 plus 1 over 2 which is equal 3 over 2 minus 2 cosine theta plus 1 over 2 into cosine 2 theta. This is d theta, and the integral is the same 0 to 2 pi and r square. Now I have to integrate this integration. So x square is as it is. Now when you integrate the 3 over 2 which is equals 3 over 2 into theta with respect to theta minus here minus 2 sine. Cosine, it becomes the sine. So it becomes sine theta. So here 1 over 2 is a constant. When you integrate cosine 2 theta, it becomes cosine 2 theta over 2, the angle 2. And then we will have the limit 0 to 2 pi. Since the value of the upper limit and the lower limit, sine 2 pi is equal 0, sine 0 is 0. Therefore, this part is become 0. Sine part is 0. Now here also sine is there. When you put it the 2 pi, the entire term becomes 0 and cosine 0 which is equal 0. So you will get the only one part which is 3 over 2. So here I will write it here. Cosine square, this is 3 over 2 theta 0 to 2 pi, which is equals 3 over 2 is a constant r square, upper limit minus lower limit. Now 2 with the 2 cancel, you will get here 3 by r square. 3 by r square. So how will you become this one 0? I will write it here. So since this value is equal, sine 2 pi is 0, upper limit, sine 0 which is 0. So therefore the entire term becomes 0 here. Similarly, this part is also same thing, sine 4 pi which is 0, sine 0 which is 0, 0 over anything which is equal 0. So therefore you will get this part. Now the next one, arc length. So how will you find the arc length? So this is the arc length for the function y equal f of x. So this is the arc length y equal x function. So this is the arc length. Now if it is a parametric function, so it is the third variable. We have to include d theta dt. So this is the formula we are going to use. Now the same thing here, find the arc length of the x equal cosine t and y equal sine t from the angle 0 to 2 pi. Now when I go with the formula, write it the formula first. The integral 0 to 2 pi is the limit of t. It is square root of dx over dt whole square and dy over dt whole square into d theta dt. Now, in order to solve this integral, I will calculate this part separately. So, I will calculate this part separately. So, let us start with this one, cosine t and y equal sine t. So, what are the derivative? Dx over dt is equal, here differentiation minus sine. Here differentiation dy over dt which is equal cosine t. Now I have to square it and you have to add it this one. So if you square it, d square x whole square and here dy over dt whole square which is equal. So when you square this part, it becomes the sine square t because the minus become plus cosine square t. So sine square t plus cosine square t, we know that it is the identity which is equal 1. Now when I substitute in the integral, integral becomes 0 to 2 pi. The within the integral, within the root, the value will be equal 1 as per this into dt. So therefore, when you integrate, it becomes t 0 to 2 pi. So when you substitute the upper and lower limit, it is 2 pi minus 0 which is equals 2 pi. So this is the arc length. So this is the same thing we have here. So when it is given the question as the speed and the rate of change, we will use the speed rule as this one. So arc of a function, when you want the arc of a function, when you need the function, we have to do it this one as a formula. So alpha to t dx over du dy over du, that is a whole square with the sum this value. So when you need the function arc length function, we will use the formula this one. And here the speed of the particle, if you want the speed of the particle at time t, we can use this formula, the derivative of this part. So the derivative and integration get cancelled, you will get the square root of this part. So here we have a parametric function parametric function here, and we want to find it the speed of a particle when the point is this, when t equal 1. So t is equal 1. So first of all, we will write it the formula, the speed formula v of t, which is equal s prime of t, which is equal square root of dx over dt whole square plus dy over dt whole square. Then I have to find it the derivative of the parametric function. So what is the parametric function here? X is equals 2t plus 3. Y is equal 4t square. Now therefore dx over dt is equals 2 and dy over dt, which is equals 8t. Now if I substitute in the formula, you will have this one is 2 square, which is 4, and here it is 8t square, 8t whole square. So which is equals, that is square root of 4 plus 64t square. Now I can take it as a 4 as a common factor. So you will get here. So 1 plus 16t square. When you take the other separate, you will get it becomes 2. So 2 square root of 1 plus 16t square. This is the t. So in order to find it the point when t equal 1, therefore the velocity, the speed is equals 2 times of root 1 plus 16 times of 1. So which is equals 2 root 17. So you can write it this one into the using calculator. The value will be 8.25 meter per second. So this is the velocity. Now the last part of this video, we have a surface area. If you want to calculate the surface area of the parametric function equation, so we have to find it this one. Here there is a one example we will give on here. Show that the surface area of the sphere. So we have a sphere here of radius r is 4 pi r square. We have to show this one is the result for the surface area. So we have to go with the formula. We have to use this formula, and since we are using the 0 to pi, we will take it 0 to pi as a t value since it is about the x-axis. So we have taken the parametric function. So it is a semicircle. It takes a semicircle. So this is the sphere we have. So this is a 0 to pi. We will take the area of a sphere of a radius 4. So the sphere is obtained by rotating a semicircle. If you rotate the semicircle, you will get the whole sphere. So the area of the semicircle, the range, it is 0 to pi. So we will take it about the x-axis. The t ranges from 0 to pi. This is the t limit. Now we will take the formula. This is equals the surface area 0 to 2 pi. This is a 0 to pi. So this is a 0 to pi. It is 2 pi y square root of dx over dt and dy over dt whole square. Dx over dt whole square plus dy over dt whole square into dt. Now we will have to take it the circle equation. What is a circle parametric equation? You have x equal cosine t, y equals sine t. This is the polar form of a circle. So polar form of a parametric equation of a circle is this one. Now when you differentiate this one, what happened? It is differentiate with respect to t. So you will get minus sine t dy over dt, which is equal r cosine t. Now when I substitute this value 0 to pi, 2 pi is a constant, take it outside of the integral. Y, I have to write it this one as r sine theta. And also we can calculate, it is better to calculate this part separately. After that substitute just. When you square it this one, dx dx over dt whole square plus dy over dt whole square, which in turn implies r square sine square plus r square cosine square. If you take it r as a common factor, you will get a sine square plus cosine square, which is equal 1. So it is equal r square. When you take a square root, it becomes just r. It becomes just r into dt. Now when we are integrating with respect to t, therefore r is a constant. Take it outside from the integral. 0 to pi r square, that is integral 0 to 2 pi, it is 0 to pi, sorry, 0 to pi, it is sine t dt. When you integrate this one, sine differentiation is cosine minus cosine 2 pi r with minus cosine t 0 to 2 pi. When you apply the limit here, the minus we can take it outside the integral. When you apply the limit, cosine 2 pi, which is equal 1, minus sine 2 pi, which is equal 1, minus 1 here. So here this part is pi, the pi value. The pi substitution is minus 1, minus 1. So you will get here minus 2 pi r, here minus 2. So minus of minus, it is 4 pi square. Thank you.